Welcome back, students, in the fourth unit, Advanced TV System. In this fourth unit, we have seen what is IP audio, what is IP video in detail, what is IP, that is internet packets, what is IP audio and video, and IPTV system, that also we have seen in detail. What is actually IPTV system? In IPTV system, what we are converting in which format, means whatever the video we are having that is recorded by a particular camera, that is being converted in which format, that is being converted into the internet packets format, and after that it is again regained or reconstructed from that internet packet format to the original video to the receiver's side at the client's house. And how all this process is being done, that we were seeing in the last lecture about the IPTV system. In that IPTV system, in last lecture we have seen the IPTV system, the content flow, means how actually the contents of the particular video that flows in the IPTV system, means how that transmission and receiver system is whatever the tasks are being performed in that transmission and reception of an IPTV system, that we have seen in the content diagram. In the particular IPTV system, we have seen in the transmission section whatever the audio and video that is being recorded by using video camera and mic in that particular video camera. Both this audio and video that is captured by that video camera, that we are transferring for the purpose of next process, that is digitization. In that we are digitizing the particular audio and video. After that we are reducing the bandwidth, means we are processing the compression, we are making the compression process here. Again that packetization process we are doing, means whatever the video we are having that is being converted into the different internet packets. And after that we are having the packet switching network, where transmission of all the packets are being done by using that packet switching network. After that, at the receiver section, we are doing exactly opposite process to the transmission. Here receiver process, we are taking packet capturing section. In packet capturing section, we are converting packets into the particular video. After that, decompression process we are performing for the purpose of getting the original bandwidth of the particular video. And after that we are performing decoding process, where in the transmission we have processed the digitization, we have converted analog data into the digital data. Here in decoding process, we are converting that digital data into the analog again, and we are getting whatever the the data or the video we have transmitted, that exactly data we are getting on the television set of IPTV. That is in short about the IPTV system content flow, or the IPTV system transmission and reception, transmitter and receptor diagram we have seen, and details of that diagram. Now let us see what is IPTV system components, means what are the different components they are present into the IPTV system in detail. The above diagram, in this diagram we can see this is the IPTV system components. There are the different components, they are present in the IPTV system, that we can see on the particular screen about the diagram. Here the typical IPTV communication system that involves content network, then head end, then distribution network, then home network, or this four, it is divided or subdivided into these four networks, and different parts of these four networks. The first head end, the head end section, that is a part of IPTV communication system, which selects and processes video signals for the distribution into an IPTV distribution network. Head end needs the different equipments, that is the equipment present in the head end, that is antennas, preamplifiers, then frequency converters, satellite dishes and receivers, demodulators, then processors, modulators also there are present, and scrambling and descrambling equipment. All these components are present into the particular this IPTV head end section. These are component, means all these components are involved in the head end of the IPTV section. Next to that, thus the IPTV system that may interconnect the head ends in different geographic regions through the use of regional or the super head end sections. Now let us see the before this particular head end section, we are having the content network. Thus IPTV system here that gathers the contents via the content network, and that is converted the content to a format that can be used via the head-end system in the IPTV communication. This content network, as you can see in the diagram, it consists of TV shows, means whatever the content they have been produced by the different producers of the TV shows, they are being taken by the content network. There is a satellite also. The satellite is also a part of this content network that is being transmitted over the satellite. After that, different channels are also involved there. Movies, audio, video, and multimedia, means all of these things they are involved here into the particular content network. And the content network gathers all the information, gathers all the contents, and they are converting that to a format that can be used by the head-end system in the IPTV communication. Then it transfers to the viewers through the distribution network. But before distribution network, in the head-end system, whatever the head-end system, this particular head-end system, we are having the switching section. As you can see in the diagram, media switch section. This media switch section or the switching section that gathers the information from different satellites, or we can say off-air receiver section, then off-air receiver section of different channel, receiver decoder section of another dish channel, and all this information that is being captured or that is being gathered by the switching section, and that is given to the encoder section for the purpose of further processing. And after that, this switch section transfers that particular information or particular video into the distribution network. Here in the distribution network section, we are having a fiber ring. This fiber ring is surrounded by the different fiber optics hub. Whatever the output of this particular head-end system, that is given to the fiber optics hubs, and the output from this fiber ring or fiber optic hubs is given to the DSL distribution unit. Then cable modem distribution unit, again it is given to the power line distribution unit. LMDS, MMDS wireless distribution unit, again the output is given to the Wi-Fi max distribution unit and optical distribution unit. All the units are consisting of different outputs from the different optical fiber optics hub, and it is given to the phone line, power line, then coaxial cables, then given to the Ethernet, Cat5 LAN, then wireless LAN, ATM broadband, and all these outputs are further given for the process to the IPTV home network system or users. Here, the IPTV data that can also be distributed by using the Wi-Fi Max technology, where the distance between Wi-Fi Max base station and subscriber station that should be up to 50 kilometers. After that, the IPTV data that can also be distributed using the optical access network. Here, it is a network that allows the individual subscribers or the devices to connect or the core network through the optical fiber cables. Okay, and after that, it is given to the network system, IPTV network users. Now let us discuss IPTV user device. As we have seen, there were the four sections into the particular IPTV system components. First was content network, head-end section, distribution network, and IPTV home network user. The IPTV home network user is nothing but the user devices. They are present at the house of the different clients or different users. This thing that involves, as you can see in the diagram, the IPTV user device function, it can be also called as a set-top box. That all of us already knew what is actually the set-top box. We all are familiar with the set-top box, and we are using the set-top box at our home. This thing, the IPTV user device, it includes here the IPTV set-top box, video interface cables, display systems, and audio systems. The IPTV typical system internal set-top box diagram, as you can see in the diagram on the screen. As this is the internal diagram of that set-top box, you can see the different blocks present into that set-top box. The broadband IPTV data packets coming to the set-top box, that may be from the different access network, that is DSL, Ethernet LAN, satellite link, Wi-Fi max link, cable modem, LMDS, MMDS link, and optical network. Any of this output that can be given as input to the broadband connections. Okay, these signals and supporting modem functions, they are available in the set-top box as an input section. Okay, output of the modem that is given to the channel decoder. You can see in the diagram, whatever the output of the modem that is given to the channel decoder here. The channel decoder, it is given to the channel decoder section for the different processes. In the channel decoder we are performing demultiplexing process, decoding process and decryption process. All this process we are performing into this channel decoder for the purpose of converting the output of modem into the next different format that are used by the next blocks. The output of the channel decoder, that is given to the different inputs, that as you can see it is given to the video processing section. The signal here, it is video signal. Audio processing section, here the signal is audio signal. And after that control section, the signal is control signal. Here are two types of signal, analog signal and digital signal. Two types of all this video, audio and control signals are present at this particular box or particular video processing section, audio processing section and control section. All these three sections. The video signal, that is given to the display unit, okay, through the suitable video interface link like RF, S video, SCART, VGA, DVI, UDI, YPB, PRR, YCB, CR or HDMI. All these things you can do it. You can send the particular video signal to the these types of different video for interfaces. Next to that, audio signal is given to the loudspeaker system. We can have loudspeaker mono, stereo, 2.1 system, 4.1 system. Number of systems are available there for the purpose of audio system. We can give it to the different systems here, so that at the output of this section, means this is nothing but the set top box internal diagram. At the output of this we are having whatever the video signal and audio signal and control signal that is at the output of this. The composite section converts the audio or it divides the audio signal, that sends the audio signal to the display device, sends the video signal to the display device and audio signal to the loudspeaker or the different stereo systems. And in that way we can view and listen the different contents of this IPTV system. This is how we can see the receiver section, or at the receiver section of the client, whatever the block that is present, that is set top box, the internal diagram of that set top box, as we have seen now. All the processing of that set top box we have seen now. Further, we can have the IPTV set-top box along with the smart card system, where we are having a smart card. We can insert that particular smart card into that particular set-top box, and we are having different keys given for that smart top box, where the same processing is being done. We are demultiplexing, decoding this signals we are getting, and then we are getting different video signal, audio signal and control signal that we are transmitting to the different devices, that is display devices and audio devices, and so that we are getting output at the receiver. Only the difference is that we are having smart card here and key for the smart card. Now let us discuss some of the features and different services of the IPTV system. The IPTV system that has more compatibility, and hence the traditional existing television systems or traditional existing television subscribers, they are migrating towards the IPTV system. The features and services provided by the IPTV system, it can be more channels. We can have the more channels on this IPTV system. More control, there can be more control, means whatever the video, whatever the application we want to use of that IPTV system, we can have, that is the more control. There are the different services they are being provided by the IPTV system. Number of services are being provided by the IPTV system. Again, instant activation, there can be instant activation for this IPTV system. The process of obtaining the required IPTV system service immediately after requesting or applying for it, there it can be very instant. We can get the access very instantly. Again, that real-time accounting and billing is also possible into this IPTV system. The channel selection, that also an important benefit, or we can call it as the feature of the IPTV system we are having here. We can select whatever the channels we want to select, whatever the package we want to select. We can only pay for that particular packet. We does not need to pay for the channels or the packets that we are not using here or we do not want to watch. So that channel selection, it is one of the most important feature of this IPTV system. Then again, multiple IP televisions per home. Number of televisions we can use per home by using the same particular IPTV service of the one section only. Again, unicast communication support is also present. Unicast transmission, that is the delivery of IPTV data to only one client within a network, that is direct delivery of the data from media to the IPTV user clients. This is one of the important feature of the IPTV system. Multicast communications is also supported here into the IPTV system. Multicast transmission, that is one to many media delivery process that sends a message to the multiple IPTV nodes in a packet switching IPTV network through the router devices. That is how multicast communication is supported into the IPTV system. Again, anywhere television service is also supported. We can watch that television anywhere. That is also one of the most important feature of the IPTV system. We do not always need to sit on our own home and watch the television. Global television channel services also provided by this IPTV system, and personal media channel service, that is also supported here. The addressable advertising service, that is also supported here into the IPTV system. Television on demand and multiple media channel services are supported. Television on demand, it is one of the most used application of this IPTV system. It is one of the most used feature of the IPTV system. It is a good feature of the IPTV system. Again, multiple conversions they are also supported by using MPEG 2 and MPEG 4 conversion devices here. Interactive televisions are also supported, that is ITVs. Digital rights management, DMR, that is also supported into the IPTV system. Means the digital right management, that is a system of access control and copy the protection that is used to control the authorized distribution of the different digital media. DMR, that involves here physical access to IPTV information, then authentication, it is called as identification and validation, then authorization of the services, encryption, that is media protection, and scrambling, descrambling. All these things are also present into this IPTV system. These are all the benefits. There are number of many more benefits of the IPTV system. Now let us discuss different protocols for the IPTV system. Till now we have seen the IPTV system in detail, that is a transmitter and receiver of the IPTV system, and what are the different blocks they are present into the transmitter and receiver of the IPTV system. Now let us discuss the protocols for the IPTV system. The IPTV, that covers both live TV, that is multicasting, as well as the stored TV, that is video on demand. The playback of IPTV, that requires either a personal computer or a set-top box that is connected to a TV. Video content, that is typically compressed using either MPEG 2 or MPEG 4 codec and then sent in an MPEG transport stream that is delivered via IP multicast in case of live TV, or via the IP unicast in case of video on demand. This IP multicast, that is a method in which the information that can be sent to the multiple computers at the same time. H.264, that is MPEG 4 codec, that is increasingly used to replace the older MPEG 2 codec here. In standards, they are based on the IPTV system. The primarily underlying protocol that is used here is live IPTV uses IGMP for the purpose of connecting to a multicast system, that is TV channel, and for changing from one multicast stream to another, that is TV channel change. IP multicast operates here within LANs or VLANs. So other protocols such as protocol independent multicast, they are used to route IPTV multicast streams from one LAN segment to the another LAN segments. And video on demand here uses UDP or RTP protocols for the purpose of channel streams and control, that is done by using the real-time streaming protocol here. A network personal video recorder like VOD, that is video on demand, that uses UDP or RTP for IPTV streams and RTSP for end user control communications. A telecommunication company IPTV services is usually delivered over an investment heavy walled garden network. Local IPTV, as used by the business for audio visuals AV distribution on the company network, is typically based on the mixture of the different conventional TV reception equipments, and IP encoders and IP gateways that takes the broadcast MPEG channel and IP wrap them for the purpose of creating the multicast streams. This was all about the different protocols we are using here into the IPTV, where we have seen for the purpose of live IPTV we are using IGMP protocols for the purpose of connecting to a multicast stream or television system or channels, and for the video on demand we are using UDP or RTP protocols. Next to that, let us discuss the IPTV via the satellite. How we are using this IPTV via satellite. Although the IPTV and conventional satellite TV distribution that have been seen as complementary technologies, they are likely to be increasingly used together in a hybrid television IPTV network, and they deliver the highest level of performance and reliability. Means satellite TV, now people are using satellite TV differently and IPTV differently, but here we are combining the two and we are forming an hybrid IPTV network where we are getting a higher performance for the particular television. IPTV that is largely neutral to the transmission medium, and IP traffic that is already routinely carried by the satellite for the purpose of internet backbone trunking and the corporate VSAT networks. The use of satellite to carry the IP that is fundamental to overcoming the greatest shortcoming of IPTV over the terrestrial cables, the speed and bandwidth of the connection. The copper twisted pair cabling here that forms the last mile of the telephony broadcast network in many of the countries that is not able to provide a sizable protection. Okay, for the competitive multi-channel TV services, a connection speed of 20 Mbps that is likely to be required but unavailable to most potential customers. The increasing popularity of the high definition television, that is with the twice the data of the SD television video, it increases the connection speed requirements or the limits of the IPTV service quality and connection eligibility even further to that. However, the satellites they are capable of delivering in excess of 100 gigabytes per second via multi-spot beam technologies, that is making satellite a clear imaging technology for implementing IPTV networks. Satellite distribution that can be included in IPTV network architecture in several ways. Simplest to the simplest, that is IPTV to DTH architecture, in which we are using hybrid DVB broadcast set-top boxes in subscribers' homes. They are integrating satellite and IP reception to give near infinite bandwidth with return channel capabilities. In the satellite distribution, we can be including IPTV network architecture in several ways. Okay, in such system, many live TV channels that may be multicasted via the satellite or with stored video on demand transmission via the broadband connection. This was all about the IPTV system via the satellite. Now let us see how we are forming the hybrid IPTV system. The hybrid IPTV that was grown in popularity in recent years as a result of two major drivers. Since the emergency of this online video aggregation site like YouTube and Vimeo, that is in the mid 2000s, the traditional pay TV operators have come under the increasing pressure to provide the subscribers with a mean of viewing internet based video. At the same time, the specialist IP based operators, they are often the telecommunication providers, they have looked for different ways to offer the analog and digital terrestrial services to their operations without adding their additional cost or complexity to their transmission operation. The bandwidth here that is valuable assets for operators. So many of them have looked for alternative ways to deliver these new services without investing in additional network infrastructure. So this trend they leads to the development of hybrid IPTV set-top boxes that include both traditional broadcast tuner and an internet connection, usually an Ethernet port also. The first commercially available hybrid IPTV set-top box that was developed by Advanced Digital Broadcast, a developer of the digital television hardware and software in 2005. A hybrid set-top box that allows the content from range of sources. They are including terrestrial broadcast satellite and cable to brought together with the video delivered over the internet via the different Ethernet connection on the devices. These hybrid set-top box, they enables the television viewers for the purpose of accessing a greater variety of contents on their particular TV sets without the need for separate set-top box and each and every services. The hybrid IPTV set-top boxes, they are also enable consumers to access a range of advanced interactive services such as video on demand and catching up TV as well as internet applications by including the video telephony, servicing, gaming, shopping, e-government access and different things via the television set. Here, from a pay TV operator perspective, hybrid IPTV set-top box that gives them the greater long flexibility by enabling them to deploy the new services and applications as when the consumers they are requiring most often without the need of upgrading of the equipment. Okay, or for the engineers to visit the reconfiguration or swapping out of the devices. This thing minimizes the cost of launching new services and increases the speed to market and limits the distribution of the consumers. In this way, the broadband, that is TV, HBB TV, the different things of the industry companies that is currently promoting and establishing an open European standard for the hybrid set-top boxes for the reception of broadcast and broadband television, digital TV systems and multimedia applications with the single user interface. Here an alternative approach we are having, that is IPTV version of the hidden in the sky cable TV system. The multiple TV channels, they are distributed via the satellite to the ISP or the IPTV providers point of presence or IP encapsulated distribution to individual subscribers for the purpose of that is required by each subscriber. This thing that can provide a huge selection of channels or to the subscribers without overburdening the internet trunking to the point of presence, and it enables the IPTV service to be offered to small or remote operators outside the reach of terrestrial high-speed broadband connections. This was all about the hybrid television IPTV system. Now let us see some of the advantages of this hybrid advantages of the only IPTV system. The IP, that is internet protocol based platform, that offers the significant advantages including the ability to integrate televisions with other IP based services like high speed internet access and VoIP. A switched IP network that also allows for the delivery of significantly more content and functionality. In a typical IPTV system or a typical system or the satellite network using broadcast video technology, all the contents they are constantly being flown downstream to each and every customer, and the customer switches the content at the set-top box. The customer they can select from many choices as the telecommunication cables or satellite company they can stuff into the pipe flowing into the home. A switched IP network that works differently here. The contents they remain in the network and only the contents the customer selects is sent into the customer home. The this thing frees the bandwidth and the customer's choice is less restricted by the size of the pipe into the home. This IPTV system also provide a means to hack into or at least disturb the private network also. There are some of the disadvantages of this IPTV system. We can call it as a limitations of the IPTV also. Let us see what are the limitations. The IPTV that is sensitive to the packet loss and delays if the stream data that is unreliable. IPTV has strict minimum speed requirement in order to facilitate the right number of frames per second for the purpose of delivering the moving pictures. This means that the limited connection, that is speed or bandwidth, that is available for the large IPTV customers base, that can be reduced to the service quality delivered. Although a few countries they have very high speed broadband enable populations here, like South Korea with 6 million homes benefiting from the minimum connection speed of 100 Mbps. In other countries, legacy here network struggles to provide the 3 to 5 Mbps, and so simultaneously provision of to the home of the TV channels, that is VoIP, video on demand internet protocol, and internet access, that may not be visible here. The last mile, that is being delivered delivery of the IPTV, usually that has the bandwidth restrictions also, only allows small number of simultaneous TV channels that stream, typically from 1 to 3 to be delivered. The service providers such as AT&T, which makes the extension uses of wireline home networking as a part of the U versus IPTV services, they has expressed the support for the work done in the direction of ITUT, which has ordered the recommendations here. These were the different limitations of the IPTV system.